discrete time Fourier transform, DTFT. Okay. The first one. First set of problems will be related to finding the DTFT. Find DTFT of following signals. A. Xn is equal to 1, 0, 1 for mod n less than equal to 2, 0 elsewhere. How to find the DTFT of this? We have to directly use the formula and get the DTFT answer. The formula of DTFT, summation minus infinity to infinity x of n e to the power minus j omega n. Okay. With this, I can solve n equal to minus 2 to 2 x of n e to the power minus j omega n. X of n is 1 in between this limit, so I have x of e to the power j omega as e to the power j2 omega plus e to the power j omega plus 1 plus e to the power minus j omega plus e to the power minus j2 omega. Okay. From this equation, I will get e to the power minus j2 omega common. 1 plus e to the power j omega plus e to the power j2 omega plus e to the power j3 omega plus e to the power j4 omega. This is equal to e to the power minus j2 omega 1 minus e to the power j5 omega upon 1 minus e to the power j omega. Okay. On solving this further, we will get e to the power minus j 5 omega by 2 minus e to the power j 5 omega by 2 upon e to the power 1 by 2 omega minus e to the power plus j 1 by 2 omega. This is equal to sine 5 by 2 omega upon sine 1 by 2 omega. Okay. This way we can find the DTFT. It is nothing but simple to use the formula correctly. Okay, to formula of finding the DTFT of this. Next, again xn is given. Find DTFT of xn. Summation n tending to 4 to infinity 3 by 4 to the power n e to the power minus j omega n. Okay. Now, I can write this as, this will be a geometric series. Okay. Geometric series whole n. Okay. Now we have to find the sum of the geometric series. This is the DTFT of given sequence. Okay. Next, DTFT of unit step sequence. This can be found. It is not found easily by this method because it does not satisfy the Dirichlet condition. So we have to see some other method. We know delta n equal to u of n minus u of n minus 1. Okay. Now delta n has got the DTFT as 1. This is equal to 1 minus e to the power minus j omega x of e to the power j omega by time shifting property. Okay, then x of e to the power j omega will be 1 upon 1 minus e to the power minus j omega. At omega equal to 0, 1 minus e to the power minus j omega will become 0. Thus, x e to the power j omega is equal to a times of delta omega plus 1 upon 1 minus e to the power minus j omega. Okay, where a is some constant and the value of this constant a is equal to pi. Okay, it is similar to CTFT function. Next problem. Input sequence xn is given as -2, -1, 0, 1 and 2. Find DTFT of this. Again use the formula. Minus j omega n. We can write this as -2 e to the power. This is my center point. Okay. At 0 I have got center point. Minus j 2 omega minus 1 e to the power j omega plus 0 plus 1 e to the power minus j omega plus 2 e to the power minus j 2 omega. This is equal to minus 2 e to the power j 2 omega minus e to the power minus j 2 omega minus 1 e to the power j omega minus e to the power minus j omega. Okay. So for this I can write in this form of sine series minus 2 j2 sine 2 omega minus 2j sine omega. Okay. This is equivalent to sine function. Next problem. Next problem will be finding the inverse DTFT. Okay. So DTFT is given and we have to find the sequence xn. x of e to the power j omega 8 cos square omega. For this you have to find the inverse DTFT solution. I can write this function as a 8 times of 1 plus cos 2 omega by 2. This will become 4 plus 4 cos 2 omega. I can still simplify this and can write 4 plus 4 in exponential form e to the power j 2 omega plus 4 e to the power minus j 2 omega divided by 2. This will become 2 e to the power j 2 omega plus 4 plus 2 e to the power minus j 2 omega. This is equal to 2 times of delta of n plus 2 equal to xn plus 4 delta n plus 2 times of delta of n minus 2. Okay, this is the time domain sequence from the frequency domain we have derived using inverse DTFT. This is one way of finding the inverse DTFT. Okay. Now another problem in which xn has got the DTFT as, okay, xn is equal to minus 1 comma 0 comma 1 comma 2 comma 1 comma 0 comma 1 comma 2 comma 1 comma 0 comma minus 1. Okay, and origin point lies at 2. From this, first question will be x of e to the power j0 is equal to question mark. Now, solution for this. We know x of e to the power j omega is summation n tending to minus infinity to infinity x of n e to the power minus j omega n. Okay, if in this I substitute omega equal to 0, then x of e to the power j0 will become summation n tending to minus infinity to infinity x of n. Thus, x of j0 is summation of all the points minus 1 plus 0 plus 1 plus 2 plus 1 plus 0 plus 1 plus 2 plus 1 plus minus 1. Okay, the sum of these 2 points is sum of these points is equal to 7. Thus 7 is the answer. Okay. Next problem. Then again this problem will be similar to previous problem. Sorry, in this case it is not be equal to 7, it is equal to 6. We have to find angle of x e to the power j omega. Okay, how to find the angle of this? See, if we look at this expression, this is an even expression when yn equal to x of n plus 2. Even signal. Okay. Now, from this even signal, it is shifted by 2. So, y of e to the power j omega is real and even because x of n plus 2 is real and even. Now, y of e to the power j omega is equal to e to the power j 2 omega x of e to the power j omega. Okay, or x of e to the power j2 omega is equals to e to the power minus j2 omega y of e to the power j omega. Okay, y of e to the power j omega is real. Once it is, if y e to the power j omega is real, thus argument of y of e to the power j omega equal to 0. Okay, once this argument is 0, then argument of x e to the power j omega is equal to minus 2 omega. So whatever is left, that is added with the 0. So this is the way of finding the argument.